Okay, let's try to solve reverse linked list today. I will try it in Python first and then see if I can implement it with C++. So the idea is we are given a linked list, let's say 1 pointing to 2 pointing to 3, which points to null. And we want to change this to be 3 pointing to 2 pointing to 1 pointing to null. And we're modifying this in place. So I believe what we do is we can set a current pointer pointing at our first head node and a previous pointer which we will start at pointing to none. And then we can store current's next variable in a temporary variable and then set the value of cur.next to be previous. So we'll change 1 to be pointing at null. And then we need to move our current pointer over to the temporary next variable. And then finally move previous over to the current, the old cur. So maybe we have to do that in a different order. Let's try that. So we will create a variable called cur and we'll set it equal to the current head of the list. And previous will be equal to none. Then we'll have a while loop and we'll say while cur is not equal to none, we will store our temp next equals cur.next, and then we'll set the current node's next equal to our previous, and then we can set our previous to be equal to cur, and then finally cur will equal temp next. And I think we can just return, let's see, at the end of this, cur will be equal to none, so we want to return previous, which will be the new head of the list. Looks like that works. Let's try submitting. All right, sweet. We got the Python version down. Let's try it in C++. All right, so I've never solved this in C++. Let's look at the definition. So we have a struct called listNode. It has a value, has a pointer to the next, and a constructor. And I guess these are not too important, but I guess the idea will be the same, but it's just that we're going to be using pointers instead of variables. So I think we might have to be a little bit more careful with our pointers here. Let's create a, maybe we want a reference to head. I wonder if we need a reference or a copy. Let's try a reference. So we'll say list node reference cur will equal head. And we will say, what is the type of a null pointer? I think null pointer can be any type. So we can say list node pointer will be previous will equal null pointer. We'll have a while loop, while cur, the same steps. We will say, let's see, temp next will be a pointer. So list node pointer temp next equals cur, and cur is a reference to an object, so I guess we use cur.next. And then we can set our cur.next will be equal to previous. And then we need to set previous equal to cur. And then we need to update cur to be temp next. And after that, we return previous. I wonder if that's that easy, unless I made a mistake here. So let's see. Non-constant L value reference to list node cannot bind to a value of unrelated type. Okay, so the head that they gave us is actually a pointer. So maybe cur needs to be a pointer. So is this setting a copy of head equal to cur? Or I guess if we're creating a variable that is a pointer, we're setting it equal to the value of the head pointer. So that should, I'm not sure if that's actually creating a copy, but let's see. If we change cur to be a pointer, then we can't be using, I think we need to use the arrow operator to dereference and set the value. And does that work? Oh, it looks like that works. Okay, we figured it out. So let me go through this one more time. We are creating a pointer called cur, and we're setting it equal to the value of head, which is also a pointer. We're creating a pointer called prev, that is null pointer first. And while cur is not none or null, we are creating a temporary next pointer, which is equal to the value of cur's next pointer. Cur's next pointer is being reset to equal previous. Previous is being updated to equal cur. So basically, we're just dealing with pointers throughout this entire loop, no references or objects. Okay, well, seems like we got pretty much the optimal solution. I guess there's an early return here for some efficiency in case the head is null, but seems like our solution works, and cool, we were able to solve it in C++ and Python. Thanks for watching.